Welcome to NASA's Jet Propulsion Laboratory in Pasadena, California. I'm Veronica McGregor. Well, the rover has just completed its Sol 3 Day 3 activities, and it has sent us back postcards of another picture-perfect day on Mars. Here to tell us about all of that and an update on all the activities, we have Michael Watkins. He's the MSL Mission Manager from the Jet Propulsion Laboratory. Michael Malin, the Principal Investigator for the Mast Camera on Curiosity from Malin Space Science Systems in San Diego. Don Sumner, a science team member from the University of California in Davis. Andy Mishkin, Integrated Planning and Execution Team Chief from JPL. And Doug Ellison, Visualization Producer at JPL. And we'll begin with Michael Watkins.
Okay, good morning. We had another really fantastic day on Mars. Curiosity, I think, continues to behave basically flawlessly, and executed all the planned activities successfully and nominally yesterday. And it's a good time for me to point out that the team operating Curiosity also is performing basically flawlessly and completing all planned activities as well. It's really just a great day all around. So the Sol 3 activities consist of a couple of things. We're about to do we're about to upgrade our software on the rover. Just like we upgrade our operating system on your home computer on your laptop or something, we're going to do the same thing. We need a new flight software load that is optimized for surface. So we landed on one that was optimized for landing, but landing doesn't have to drive the rover and operate the arm and all that. And by the same token, the surface doesn't have to land the vehicle. So we want to switch to this new flight software that's really optimized for surface operations. And we're going to do that starting tomorrow. Actually, day after tomorrow, sorry. Sol 5 is when we're going to start that activity. So we had to do a little prep work for that activity. We want to check out our backup flight computer and make sure that was healthy and it looks fine. We also sent up some files to get ready for the flight software transition. Now, the other things we did was check out some more of our instruments, do some more health checks on the remaining instruments. And so we checked out the SAM instrument, Chemin, APXS, and DAN, and they all passed those checks successfully. They're all in great shape as far as we know, through the tests that we've done, and that's a great sign. And no anomaly showed up at all in any of those tests. We also took a whole lot of imagery around us. So we took a 360-degree panorama of using the nav cams of the terrain around the rover, and also looked back at ourselves and took a close-up of the deck. We also took the first 360-degree panorama in color that Mike Malin will talk about a little bit, and started to get the first bits of that down. So let me start by showing some of those images.
You can watch it up there, I think.
Just make sure it turns. Okay, so this is our deck pan, and now we're kind of zooming in here. And you can see here that that's actually the RAD instrument, and you can see a few of these kind of large for us pebbles on the surface, and those apparently were kicked up by the landing event. Apparently, our Mars lander engines actually pushed up some of these this gravel kind of stuff, maybe up to about 1 centimeter in size, on top of the rover, and they pose no problem for operations. We do move the black thing there, the differential pivot around, but can easily go over these or crush these or not even hit them at all, go on top of them. So we don't see any operational constraint by this stuff being there, but it's a little unexpected that it is there. The EDL team, when they analyzed the landing before landing, I think they didn't think they would kick up stuff this large. And so I think they're off looking at that. Maybe these are lighter material than they expected or something like that. But the EL guys, they have nothing to do now, so they need a problem to go start working on, right? So this is something for them to do. But as I mentioned, we don't see any impact of this. The RAD instrument and our other instruments don't seem to be, they're not covered by any. It's not affecting the science observations. So we think that all that's in pretty good shape. Let's go to the next slide. Okay, so this is just kind of a context shot here. Here we are. You can see the high gain antenna there to that's the hexagonal thing pointed off to the side there, and then behind it, the little thing sticking up is the low gain antenna. then you can see the rim of the crater off in the distance there. And we also acquired some color pans of this area, and Mike Meelan will talk about those.
Thank you, Mike. Here I am again. Only I'm wearing another different hat this time. I'm the principal investigator of the mast camera. And before you've seen me here is Marty, the scent imaging. And we got a 360-degree panorama into the sequence from yesterday. And we got our thumbnails back. And I need to tell you that the full frames are now stored inside the camera, and we do have to get those images out of the camera and stored into the rover's memory in order to bring them back home. But today, the saw we're planning now for is the last saw we have until after the software activity goes through to get them queued up. So we're going to queue up a few of the full resolution images. Again, what I'm showing you are thumbnails. You should remember back a couple of saws ago when I showed you the thumbnail of the heat shield, and then I faded that into the full resolution. That's the kind of difference you should expect to see between what I'm going to show you now and what I'll show you when we get some of the full resolution frames back. So if you can have the animation, please, the video. This is the full 360 panorama. It's the color as it was transmitted, except brightened up. It was pretty dark to begin with. You see there in that area going off to the right now the impact, or the plume impact site of the rocket plumes. We're now panning across the base of Mount Sharp. We see the shadow of some of the hardware on the rover itself. We zoom in because there's a big gap of places we didn't take pictures, so this gives you a better view of the tier of images that we did get. You'll pick up the rim up at the very top and the haze. Haze shows up pretty well in the color. You can see it's slightly different color. You can see it's a low light layer there, as was seen in the nav cam. And then we're going to zoom in here again to look at this is the area that's been discussed. It was shown last time I was here. Grotzinger talked about bedrock and digging up material by the rocket plumes. So if we can keep going now, I think we're going to back out from this and just show you the full mosaic again and zoom in back to the other plumes. And then we're going to zoom back into the plumes. So you can see the plumes are light toned. That could be a contaminant. We don't know. We probably won't know unless we go over and observe these things. Other than that, this is a very low resolution image. The images are only 144 by 144 pixels. There are 130 of them in here. It took us about an hour and 6 minutes to take the mosaic. And with that, I'll hand it off to someone who's going to interpret some of this stuff.
Yeah, so we have these beautiful images, and Mike did a nice job describing some of the interesting features we can see in the early part. We're really looking forward to the full resolution images. We can also see the main reason we chose Gale as a landing site. So if I could have the first slide. So this is the NavCam mosaic, and in the upper right you can actually see the main target area of where we want to go and why it was chosen. So in the hills at the background at about between 190 and 200 degrees at the top, you see these beautiful knolls and of layered rocks, and that is those layers are what's recording the history in Gale Crater, and they are one of the reasons we chose Gale Crater. The main reason is to study those rocks, so we can see those in the distance from where we are, and It's very exciting to think about getting there, but it is quite a ways away. And we also want to be able to take the science that we can do where we landed and integrate that into the mission as well. So next slide. I've been coordinating with some others a mapping effort, and so you can see in this image you can see the landing ellipse outlined in red, and we've divided the area up into about 1 mile by 1 mile quads or squares, and we had volunteers from the science team map each quad. And what mapping means is looking at the different textures that you can see in the images and mapping the boundaries between those textures. So if we do that for geology on Earth to mark where different types of rocks are outlined. And Curiosity landed in Quad 51, which happens to be one of the ones I mapped. So I'm sure that was intentional by the navigation team. And so what the science team is now doing is we have these individual maps, and we've started integrating them to get the broader picture, and also investigating the rocks and and craters and patterns around where Curiosity is now. And we'll use this map to find a path from where we landed to the main target at the base of Mount Sharp, which is south of where we landed. And so we'll drive on the northwest side of the dunes and go through a break in the dune field. But on the way, we're going to have a lot of interesting geology to look at. And so the team will be balancing observations and scientific investigations on our drive, but also still get to the base of Mount Sharp. If I could have the next slide. This is the Quad 51, where Curiosity landed. And you can tell by looking at this image that we have several different textures of rocks and surfaces in this. And the team is focused on what are the key observations we can make here that will tell us about our landing site. And then we will go from those and choose a path to the base of Mount Sharp, doing the best science that we can along the way, but also keeping our eyes on that beautiful layered rock at the base of Mount Sharp.
Okay, well, you're hearing about these great results and images coming back and what they mean. I'm here not to talk about those, but talk about what we're doing all day in our mission operations in order to enable getting those results back. And my team is the team that does the command sequencing and integrates things coming from the science teams. And it's a challenging issue to actually do the operations because we can't joystick the rover due to the time delay and a number of other reasons. We have a very highly resource-constrained vehicle. The amount of power that we're getting from the RTG is basically a little bit more than that you need to power a 100-watt light bulb you might have in your hallway at home. And we need to also deal with the data volume and basically make sure that we can fit the data that we get into our next available opportunity to get data down through our orbiter relays. In addition, we have to make sure that we can actually achieve what we want within the time that's available to the rover, because it can only do things so quickly, and get that done in time for that downlink. We can only communicate with the rovers a few times per Martian day, and we have to fit those things in. So. In addition, we also have to deal with all the conflicts of trying to manage all of the different types of activities that the members of the science team and engineering teams want to do, so that, for example, we don't try to point the masts to take mast cam images in one direction at the same time that we want to be pointing to take engineering camera images. So there's hundreds of those rules that we need to manage, and all of that takes time. And our solution to dealing with the challenges is effectively we're writing a software program every day that has to run the first time when we send it up to the vehicle it's going to operate on to tell the rover what it's going to do over the next day. And that really involves a combined team of engineers and scientists who are working together over the course of 16 hours, basically every Martian sol. And if I can get the graphic, this is just a brief summary of our process. And one key point of this, you'll see that all of this that's going on is pretty much when the rover is asleep. And so that's why I call it the overnight timeline. From the standpoint of the rover, we're doing all of our work when it's not really doing much activity except for maybe some brief wake-ups for nighttime operations or communications. And in this process, we've got starting point in the timeline where we get one or another orbiter pass bringing down data from basically the rover's late afternoon and getting that on the ground, which has some data volume that's going to vary from sol to sol. We produce the products that we need to in order to be able to see the images, have them constructed, and the other telemetry. And then our engineering teams and science teams are assessing and making sure that the rover is healthy over the course of a few hours and looking at the results so that we can, based on that, decide what we want to do and what the next steps are for the sol that will follow. At that point, we end up in a meeting where we end up addressing those items and bringing the key issues to the fore, and that involves about 20 folks at that point. In parallel with all of that, science teams and engineering teams are looking at the activities that need to be constructed into a coherent plan for the next sol. When that is put together and deconflicted and we've made sure that we aren't violating any of the hundreds of constraints, we will review that for a group of scientists and engineers. It may be about 40 people, and we're kind of ruthlessly sticking to this timeline because all of this is leading us to our command opportunity. After having that plan, we then turn those into command sequences, which is effectively this software of up to maybe 1,000 commands that are going to be executed to govern exactly what the rover is going to do over the next Martian day. When we've proven to ourselves that we haven't created any issues and that everything will execute properly, then we approve that and uplink it. And you can see in the graphic the deadline of, well, we have to hit that deadline when we have our communications opportunity, because that's our one time to really tell the rover what we want it to do and get that up there. And then it operates on its own until it can communicate back in the afternoon the results of what's happened. And so that's the basic cycle that keeps really over 100 people busy over that 16-hour timeline and really running a sprint every day to make sure that we can meet that mark and keep the vehicle productive and gathering science. We're doing a flight software transition. So I'll turn it over to Doug.
Thanks, Andy. Exactly a week ago, I was sat here and was introducing you all to a tool called Eyes on the Solar System, which lets you ride on board with many of the spacecraft that are exploring the solar system, and in particular, the module specifically made for Curiosity's entry, descent, and landing. And I didn't want to spoil the surprise at that time. I didn't show you all the way to landing. I didn't want to spoil things for you, but that surprise, it worked. And I would come back just to kind of give you an update on how that went, how accurate we were, how many people were watching, and other things you can still do in Eyes on the Solar System now we're on the ground. Yesterday, Jennifer reported to you our touchdown time on spacecraft time, 10:17 and 57.3 seconds. The navigation team, led by Fernando, they gave us a trajectory 3 weeks ahead of touchdown. And our touchdown time was 10:17, 57.9 seconds. We are 0.6 of a second out in Eyes on the Solar System. We're very pleased with that. Most people were probably having more inaccuracy based on the clock on their own computer rather than the trajectory we had in there. I also want to thank Steve Collins, one of the attitude control engineers who was in the darkroom during landing night. We were on console in the afternoon. And Steve was furiously gesticulating to us through the window to tell us that he had a slight tweak for us for the pointing of the spacecraft, and we got that in before the big traffic arrived on Eyes on the Solar System at about 9 o'clock in the evening. Between Saturday and Monday, we had 973,000 visits to Eyes on the Solar System. Landing night alone, we had 739,000 visits. Our servers pushed about 20 terabytes of data over the weekend to give people this amazing experience of riding on board with the spacecraft. And it wasn't just those people at home. Some of those visits actually kind of doubled forwards. We had there was an event at the Deep Space Network down in Canberra led by Glenn Nagel. They were using Eyes on the Solar System. Hundreds of people were watching there. Phil Plait, the bad astronomer, he was actually streaming it live into a Google Hangout. The Oregon Museum of Science and Arts, the Oregon Museum of Science and Industry, the Museum of Arts and Sciences in Georgia, and of course Planet Fest just down the road here in Pasadena. We're all using Eyes on the Solar System to let people see what was happening through the evening. In total, we've had reports of about 65 different landing events which were using eyes, and we've had kind of statistics on about half of those, which adds up to almost 8,000 extra visitors as well. And we are going to be replacing the trajectory that was this massive 0.6 seconds off with a reconstruction at some point in the future. Once the EDL team have had a chance to digest all of this data they'll be getting back from the various instruments on board the vehicle during landing, that will be turned into a reconstructed trajectory that will then be put into eyes, and then we'll let you know when you can actually see the actual series of events. It turns out we're about 1 quad away from the actual landing site. I think we're in quad 64. I don't know how interesting that is, but once we get the new trajectory, we'll put that in. But in the meantime, there are still things you can find in eyes. There are still some interesting things, and we had people sending us some of their favorite things during landing night. If we can cut to the live feed, one of our favorites was this one. It's the donut shot. It's people putting the camera right behind the vehicle just before cruise stage separation. You don't need to duck, don't worry. And we had people sending us different screenshots of the kind of things they were doing. One guy had a triple-wide desktop machine sat on his desktop watching all of this landing inside eyes on the solar system. I'm just going to skip through a few of the things that you can still have a look at. Mike was here yesterday talking to us about the ballast impacts that were spotted by the CTX camera on MRO. Here is that ballast leaving the spacecraft in eyes. The trajectory was given for all 6 pieces of ballast. And in fact, the picture's at the back of the room there, but the impact site was, I believe, somewhere around this little mesa down here. And again, when we get the reconstruction, we're going to put that in back here as well. Touchdown was a little bit off by those 0.6 seconds. The actual landing site is not far from here. In fact, if we zoom out, we can actually show you how far off we were. The real landing site's just about here, so we're not too far off. But we'll be moving this beautiful terrain model to bring it up to date when we do actually have that proper location. And of course, we even have the Sky Crane flyaway that, just by good fortune, happened to be in roughly the same direction as the real descent stage flyaway. Off it goes to a polite, safe disposal. And there's even more. If we go to Sol 2, you'll notice we've swapped the rover around just to point it in the right direction. And we're taking it out to the moment in time when the mast was actually deployed on the afternoon of Sol 2. And I'm going to fast forward because the stand-up takes about a minute. But there is the stand-up. And turning around to that sun, the anti-sun position. And, of course, you can see Mike's 2 beautiful cameras right in there. And this doesn't live in isolation, of course. It lives with all the other spacecraft in our solar system. So if we leave the EDL module, you can see the whole of the solar system. I'm just going to go back to Mars and to the present moment of time, which is right now. This is where things are right now. You can see Curiosity in the landing site right here in Gale Crater. It's nighttime right there now. But we have Odyssey, we have MRO, and so in eyes, I mean, in fact, Emily sent me a question a few days ago, was there a lookup table of communication passes? And I suddenly thought, well, actually, you can find them right in here. If you fast forward through time, you can see, as the planet rotates underneath, you see the 2 orbiters going overhead. And so that would be a communications pass there as MRO goes overhead. Another one for Odyssey right there. Every 2 hours or so, these spacecraft fly over the landing site. And then when you get the sunrise, of course, we can go into the landing site. And we can see the sunrise in the east, right next to Mount Sharp. And so all of these things are things that people can still do at home. And we'll have news for you when we get this reconstructed trajectory, probably in a few weeks' time. But with that, I'll throw it back to Veronica.
All right, thank you. We will start with questions here at JPL, and then we will go to some questions on the phone line. I'm going to start here in the middle, and then we'll go over to Leo. Oh, and you as well.
2 real quick ones. Mike, the colors that you're showing us in these images, are they natural color or white balance color?
They are. You want me to answer them? They are not white balance. They're what the camera sent back. I just brightened it up because the illumination at Mars is much less than at Earth, and we were concerned when we set the exposures to be able to make sure that if there was something glinting that we didn't saturate the detector. So the images were pretty underexposed for a normal photographer, so I just brightened them up, and that's just what the Bayer filter gives you when you look at Mars.
And for Doug, since you simulated the flyaway of the Sky Crane, can you estimate the angle at which it struck the surface?
I could eyeball it. I'm sure the EDL team will be on a panel tomorrow. They can give you a better answer then. It's I would something around 45 degrees I'd have guessed, but that is just a kind of an eyeball guess based on this. The EDL team will be the best people to ask tomorrow.
Let's see, we've got one question up here in the front, and then we'll go to one on the phone line, and then I'll come back to you, Leo.
Thanks. Jonathan Amos from BBC for Mike again. Can you just compare what you have got with what you will got? Give us a sense of just how much bigger in terms of scale this other image is when you get the whole thing, and will you sort of fill in the top as well so that you've got the
data volume will be 64 times larger because these are 1/8 sub down. The resolution will be 8 times better. So these are extremely reduced versions of what we will be getting. In a sense, you may know we originally proposed zoom lenses, so I'm basically giving you a slow motion zoom. We've got so we got a low resolution camera, and then we're going to take a higher resolution camera, and eventually we'll use the 100mm lens, and that'll get you even closer. But for now, this was pretty enough and interesting enough that we thought it was worth sharing with you guys. We haven't filled in the top, and we actually have you saw there's some gaps in the bottom as well. Those are not really in the plan right now. This is the first. We hope we'll get many others, and we hope at some point they'll be guided by science and not by just taking a random picture. This one had to be planned. This one was planned in November of last year. So what you see is what I thought, and it was completely independent of where the vehicle is pointing or anything else. So it's a random shot where you land, you turn, take a picture around, you land, or you swirl your tripod and take a picture. It's probably not the best pointed. It's probably not, doesn't include everything that you'd want. We're hoping as we move out of the characterization activity phase that we can start putting in and getting better things.
Yeah, let me add one thing about that, because Mike raised a good point. Most of the activities that we've executed in this characterization activity phase, the CAP phase we call it, were actually uploaded to the vehicle a couple of months ago, actually in cruise. And that's partly because we wanted to check them out very carefully on the test bed and make sure they were 100% guaranteed to work here in the early days of the mission. There's some unusual first-time activities, and we wanted to check them all out. But it also means we had to pre-build them before we knew exactly what to look at, right? We didn't know exactly where Mount Sharp was going to be and things like that. But in addition, Andy talked about his team working on on this tactical timeline that's very pressing. So we also wanted to reduce the workload. We're trying to flex our muscles very slowly on the rover, and we're trying to flex them a little bit slowly on the team as well. So we wanted to have more stuff pre-built so that we didn't have to build, write as much of that program as Andy was saying each night. So as Mike indicated, these are kind of the pre-canned activities, and now that we can optimize, we know where we are, and we can do more optimal targeting coming up here shortly.
I can add that in the CAP intermission, which you've heard about, and I think I had a question from the audience, that we do have some mosaics that we are going to be able to move a little bit. They were planned to be moved. We have placeholder positions, and as we get into the phase where we can do that, which is after the software update, which is critically important to us as well as just the running the vehicle, then we will move them around. And one of those we hope to shoot with 100. We haven't taken any 100mm focal length camera images yet, and there are none that were preloaded to the vehicle. So there's still that instrument that needs to be checked out, and we're going to try to shoot Mount Sharp with that.
Okay, we're going next to the phone line. Denise Chow, space.com. Go ahead.
Hi, thanks for taking my question. I think this is probably for either Mike or Dawn. With the color panorama, are there certain features that you're better able to see with the color as opposed to black and white, and are there things that you didn't notice at first that came through in the color shots?
You want to take it, or you want me to?
Either one. Why don't you take it?
Because color and albedo, color and brightness on Mars are often very closely correlated. I don't see anything personally in the color that I didn't see in the grayscale image. But I'm trained. I know what to look for. And I think the importance of this mosaic really at this point is that it can show everybody can see the differences. And the color, the discolorations that you see around the rocket plume areas, and the color and brightnesses of the rocks in Mount Sharp in the far field, those are indicative of real differences. We're not sure what the differences are, but they're real differences, and they're much more easily seen in color. The human perception system can discriminate something on the order of 1,000 different colors, but only about 60 different grayscales. So this gives you 1,000 to 60 information, a factor of 10 more information. You want to try?
I will say that the engineering team, it was a little easier to see the dust on the rover in the color image than it was in the black and white.
All right, going next to Leo Enright.
Leo Enright with Irish Television. These briefings take place just as the evening newscasts are going out in Europe, so timing is important for us. Could you? I had in my mind that this full-res pan would be available tomorrow. That doesn't sound correct now. So I wonder, could you be specific as to when you think, in Earth days, when you think that pan would be available, and also when you think we might get Aeolus Mons in full, or Mount Sharp in full in terms of Earth days? And if I could, just a supplementary, how tall is the rim of the crater that we're seeing? I mean, how high are those cliffs?
There are lots of parts of that. I'm going to try to address some of them, Leo, but I don't think I can do it all. I don't think we're going to see more than a couple of dozen of the full resolution images from this panorama until after the software upload. And it really depends, because that's all we're putting commands to load. The idea here is you take pictures with your camera. They're in your camera. What do you do with them? Well, you physically take the card out and you put it into your computer. Well, I can't do that with my cameras, so I have to ask the rover to go get them and put it. And we've only put in a request to do something like 20, 24 images to pull them out of the card, and today is the last sol that we have to be uplinking commands for that. So that's fine with me. We get past that point. Now we get in a couple of 5 sols. We get to get some more back. We are also limited by bandwidth. These are the full images are going to be 4 megabits each. They're 2 bits per pixel, and so that's a large volume. 130 of those frames. That's getting up to the several hundreds of megabits. Some of the things are going to take on during CAP. That's going to run into the gigabits, and I'm not expecting to see many of those come back for quite a while. We don't have the bandwidth like a DSL or a cable, so there's that issue. What was the last part of your question about? Height above the crater wall. There are 2 parts with the problem with the crater wall. The northern crater wall is actually lower than the peak of Mount Sharp, and the northern wall, which we can't see because Mount Sharp is away, is probably a little about level with the. So we are obviously below the height of that wall, but it's because we're not seeing out from it. But it's probably, from my recollection, it's only about 2 kilometers higher than where we are right now.
Okay, we're going to go to the phone next, and then we will come to a question in the room. Keith Cowan, go ahead.
Keith Cowan, nestwatch.com. Question for Michael Watkins or anybody else who might answer. On several of these photos that have come down, there's the augmented reality or AR tags. I've seen several. They look like little pixelated versions of the rover. And in the captions, they say that they're going to be used with future apps with smartphones. 2 questions. Is there an app under development by JPL, and if so, when are you going to release it? Second of all, are these going to be, closed apps where they just get pushed out, or are you going to attempt to make these open, like Google Earth and so forth, so that other people can take the data and add on to it and create their own versions?
Keith, I can take that one. I'm not sure the specific timeline for the app that's going to use the AR tags. It's something that is in progress. You're probably best putting in a question to Mars EPO for that. But there are other experiences already online. There is a free drive online experience. There is an experience to see where Curiosity is and see what it's getting up to. Want to learn about the rover as well. And the Be a Martian app. But the Be a Martian app's already open source, and I believe there is work in progress to open source all of these other ones as well. I hope that answers your question.
Thanks.
Okay, in the room here, we're going to go here in the middle.
Thank you. Steve Gorman with Reuters. When was the color panorama images that you're showing today? When were these taken? These were taken on Sol 3, during Sol 3? Or?
These were taken 11 o'clock last night here, PM PDT.
All right, so that would be Sol 3 for Mars.
Yes,
right?
Yes,
Sol
Sol
3 on Mars.
Sol 3 Mars.
Okay, and then also, what health checks were done on around the same time frame, the same day? You said that you checked out a number of instruments, and also I wonder if you could just tell us, like at this point, what instruments have now been sort of checked, and are there a number of instruments that you've sort of now checked, and we've deemed them so far to be okay, they're operable, and they're functioning all right?
Well, so I think for the first question was, were they all done on the same Sol? Yeah, everything I listed was the Sol 3 activity, the online RCE checkout, the APXS, DAN, Chemin, and SAM health checks, and both the NavCam and the MASCAM 360 pans. That was all done. Those are all Sol 3 activities. The other question was which instruments have been checked out. So they've all been checked out, but there are different levels of checking them out. We do if I turn the circuitry on, does electricity flow all through it? Is it basically working? There are some mechanical checkouts, for example, inside SAM that have not been conducted. Can I move things around inside SAM mechanically? Those have not been done yet. And then the scientific characterization, the calibration and the full performance of the science instruments has not been conducted yet. So we're kind of just starting off slowly here, making sure they all turn on and they all execute their first level functionality. And in some cases, we actually have that in science. The RAD instrument is working quite well. I think Don Hassler talked about that. We're getting images from Mike's cameras. So we're starting to unroll the science slowly. But there are these more advanced modes of the instruments still to be looked at.
All right, thank you.
Okay, we've got one more caller on the line, and then we'll come back to the room. We'll go now to Ian O'Neill with Discovery News.
Hi there. This question's really for Mike Watkins. I was just wondering about the debris on the deck of Curiosity. Firstly, why wasn't it anticipated that the debris of that size would be on top of the rover? Also, are there any instruments that are vulnerable to it, and will there be any follow-up study? And also, will these pieces of debris remain on the deck for the duration of the mission?
Okay, so it was not predicted because the propulsion folks and the EDL team they tried to figure out how much the pressure exerted by the engine exhaust would be on the Martian surface, and they took a guess at the range of particle sizes, and they simulated that, and they felt that it probably wouldn't kick up things this big. So obviously that means these materials lighter than expected, or the exhaust was a little stronger than expected, or closer to the ground than expected, or something like that. But let's let them look at it for a while and come back with a full explanation. We don't think they have any impact on us right now. There were some potential things could have landed on top of the RAD instrument detector, for example. But you saw Don Hassler's results yesterday, and they look fine, and so there's no indication there's a problem. We look at the deck, and we don't see anything like that. So some of our other instruments could have been impacted by one of these pebbles, but we haven't seen any evidence of that yet. So as far as we know, via the instrument checkouts, they didn't hit anything. And in terms of mechanically obstructing any of the things on the rover, there's no problem with that at all.
Okay, back in the room
The last question, by the way, was how long are they going to last? We don't know. I think when we start tilting around, some of them will probably move around and fall off.
Okay.
Hi, this is Mark Kaufman of the Washington Post and National Geographic. A question for Andy Mishkin. You had said that on a daily basis you're sending 1,000 commands or so up to Curiosity. Have there been any anomalies, or is this something that is going, that it's just reading it in a kind of near perfect way?
Well, I will say that in this early set of sols with some of these things that are already on board. The number, the commands being actually uploaded every sol is a little bit below that. That actually is representative of really the combination of the things we're uploading and some of these things we have on board, where we anticipate we'll have something of that order when we're fully in the nominal process, where we don't have any of this pre-built stuff. But we aren't really having any trouble getting things on board. We've had some small shakedown issues just related to getting in the habit, but we haven't had any serious issues getting our commands on board.
One other question, if I could. You were in the diagram. You showed that both Odyssey and MRO were being used in terms of transmission. How about the European satellite? Is that something that can and will be used?
Well, we do have plans. I'm not sure exactly which sol to work with MEX, but that has not been used to date.
Go over here on the aisle.
I have two questions. First, for Emily Lochtewal at the Planetary Society. For Mike, what kind of downlink data rates are you achieving from the rover right now, and when are you going to be able to ramp up to the 2 megabits per second that we're talking about with MRO?
This Mike.
Oh, sorry.
We've been up to a few hundred K data rates so far. We start off very low. We start off at 8K and 32K, and then we ramp those up slowly as each of them proves successful. Probably in a week or so, we're going to continue to increase those data rates and turn on what the specific question was, adaptive data rates. So MRO, the radio on MRO and the radio on MSL, they can dynamically adjust the data rate. So when the link is very strong, when MRO is very high in the sky, you can up the data rate to the maximum amount, up to about 2 megabits per second. And so as we continue to progress through the through the data rates, we'll get to that probably in a week or two. We're being a little bit cautious here because of the flight software transition. But Mike Malin was talking about the backlog of data, and it's pretty important to us to check out the telecom system very carefully and very fully, so that we can up these data rates and get more of the data cleared out of the camera buffers, where they can store gigabytes of data. And so we're trying to get the data rates up as fast as we can, but we're kind of pausing during the flight software transition.
And then for Malin, my impression from both the NavCam and the MASCAM images is that this is a much more colorful place than we've ever landed before. Is that a correct impression? And can you speak to what that means scientifically?
That's my impression as well, but I've spent actually almost no time looking at the NavCam. And I just saw this thing when I came in very early this morning. Some of the coloration we're seeing here really has to do with the sand dune. And you see that the dune field is dark, and in this kind of a camera will look sort of a little bluish. And so there's dark sand, there's the red dust, and there's the substrate rock, which is tan or light toned of some type. Those are all the basic elements that we've known for Mars from telescopic observations, from the 50s and 60s all the way through to our most recent missions. Just looking at color can't tell you enough about the composition. It can also be a factor of texture, as we found in the MER sites, where we thought we were seeing layers in the layered rocks that had different compositions, yet generally they were the same composition. Certainly nothing that you could tell optically would be different. So the way dust and sand are trapped by a surface will also change their color. So I can't say it's a more colorful or diverse site than others in terms of just on the basis of the photometry or colorimetry, but obviously geomorphically it's a very diverse place, and I'd expect we're going to see lots of patterns from that.
If I could add something to that, we've been looking at the high-rise and mapping, and when you start looking in detail, there are a lot of variations in the texture. And one of the things we're going to be working on is mapping these images that we see, in particular the Marty descent images, onto the high-rise ones to really try to see what that diversity is. And we're very excited that there are a lot of things to look at. And as Mike said, we don't know that they're the same, whether they're the same or different compositions, but they certainly have different textures, and we're hoping the color can help us guide us to some variations as well.
Okay, Todd Halverson.
Todd Halverson, Florida Today and USA Today. I am wondering if you can tell us what you're going to be doing in the next 24 hours. It sounds like you're going to start the software upgrade, and I was wondering how long that takes and whether you can do anything else during that upgrade, or if that's just what you got planned.
Well, on that actually starts on Sol 5 rather, and those flight software transition days 5, 6, 7, and 8 were pretty much devoted just to that flight software activity and not to science. So we're kind of standing down from science, as Mike Malin indicated. And the reason is we have two computers. Think about when you upgrade your own software and your computer's down for a little bit. We have a bunch of copies of the flight software, and we have some backup copies. And so you would sort of load it into one and load it into another, and then turn the other one on, load that one on, and verify each of those intermediate steps. And sometimes you're stuck in this mode where you have the old software on part of your computer and the new software on part, and we didn't want to start trying to do executing other complex activities in the middle of that. So we kind of stand down, and we'll be back to science the day after that, Sol 9.
This is the first time I've heard Mike refer to this type of as a change of a software. I sure hope he does better than what I've done on my machines. We are going to get downlink, aren't we, through the...
Okay, we're going to go up here. Oh, quickly, and then we've got about 5 more minutes.
Could you clarify what day, Earth Day, Sol 5 is?
Saturday, right?
Yeah, it starts on Saturday.
Okay, let's do one here at the front of the room. And again, we've got about 5 minutes left to get a couple questions in.
A question is Jonathan Amos, BBC again. It's a question for Dawn. In your quads, you showed us on the NavCam panorama where you wanted to head to. I don't know if you could show us in which quads that is.
It's actually not in any of the quads that we've mapped. So actually it is. It's about 120, 121, 134, 135. So down towards the bottom.
Yeah.
Is the area that I was pointing to in the NavCam.
Okay, and the second part of my question was, has there been any discussion in the science team about using the ChemCam laser on the scour marks, or is there so much contamination there it's just not worthwhile?
There's been a lot of discussion, and there's an awful lot of eagerness to know what the composition of those rocks are and to use our laser.
Calif Sky and Telescope, also for Dawn. In mapping this area with the orbital imagery that you had available, does it look like what you expected to? Few rocks, lag deposit, whatever?
Nothing. Almost none of the rocks and details we can see in the foreground are visible from the orbiter images. And so this area we identified as being smooth, and we sort of have a number of units. And this was one that in compiling the maps, it was very difficult to interpret what it was. And so the images, the NavCam and MassCam images, have given us our first sense of what this terrain is like. And we are now discussing what it means in the broader context, ways that it might have formed, how we can actually, what observations we can make to understand how it formed.
Okay, any more questions here in the room? All right, then that will be it for today, but I want to remind everyone that we will be back tomorrow at 10 a.m. Pacific time. We'll have a longer format press conference at that time. We'll have our daily update, but we will also have the entry, descent, and landing team come back to present their reconstructed data from landing and a lot of details about that. So please join us again tomorrow, and thank you for joining us today. Broadcasters, please stand by for the replay of images.